In this video, I will be demonstrating the half adder circuit. So firstly, the components of the circuit. So we have a power jack here connected to a 9-volt battery. Then we have two push buttons right here. We have two 10K ohm resistors, two ICs, the left one being an XOR gate, 4070, and then the right one being a 4081 AND gate. We have two LEDs here, the yellow one representing the carry and the red one representing the sum. Then we have two resistors here. We have they are both 470 ohm resistors, and then we have some wires connecting the parts together. So before we start explaining how the circuit works, I want to give a brief demonstration on how binary addition works, as it's a key part in understanding how the circuit works itself. So these are four scenarios that would help you understand how binary addition works. So we have here 0 and 0. 0 and 0 equals 0. 0 plus 1. The two inputs, 0 plus 1 equals 1 as an output. Then we have the two inputs 1 and 1, which equals 0 on the first column as an output, and 1 on the second column as an output. So we carry over the 1. Then if we have 1 plus 1 plus 1, this is where it gets pretty tricky, and that's where this is coming into place. You add a 1 here, as you want 1, 1, right? You want 1, 1, but you want to carry over the 1 to this side. And the reason why I'm saying you want these two 1s for each column is because this exists here. When you have binary numbers, each column represents a amount and a value. So the first column represents 1 as a value. The second column represents 2 as a value. Third column represents 4 as a value. Fifth column represents 8 as a value. And yeah, as you can tell, it's a pattern, right? It's multiples of, so you take the number and then you times it by 2, and that's going to be the next number. And you can do that into infinity. So that's how binary works. And the more columns you have going to the right, the more numbers you are going to have. And it's just multiplying by 2. So you can practically make any number you want. I'll just give a brief example here. So if you want a number of, for example, a number of 10, right? You want 10. How to get 10? It's pretty simple. You need, you need 8 and 2, right? 8 and 2. So that would be 1, 0. Oops. 1, 0, 1, 0. This right here would equal 10, because you have 1 being 8 and 1 over here being 2. 8 plus 2 equals 10, and then you have 0 4s and 0 1s. So I hope that kind of gives you an understanding quickly of binary addition. Next, to move on to the explanation of the circuit. Thank you. So now to explain how the half adder circuit actually works here. So firstly, half adder circuit demonstrates kind of how binary addition is used in a circuit, and it also demonstrates the logic. It also demonstrates the logic gates that we have here, which are the AND gates and the XOR gate. So the AND gate works by having two inputs, and if both inputs are true, you have a result of true. So that's demonstrated right here. 1 and 1, two inputs are true, and you have a result of 0 and 1. So you have a 1 here. Then if we go to the XOR gate works if you have one input is true and the other input is false, you will have a true over here. So I've also labeled them. So we know what they are once I come back to the circuit. So button 1 is the first input, and button 2 is the second input. And then we have sum and carry, and sum is the red light, yellow light is the carry. And as I have shown, the XOR has a 0 and a 1, which is the XOR gate logic. If you have 1 false and 1 true, you'll have an answer of true. If you have 1 true and 1 false, you'll have an answer of true. So this table makes sense and kind of gives a pretty clear demonstration on how the logic gates work and how they work with binary. So those are 3 situations that we'll come into. And now to demonstrate those 3 situations on the actual board itself. So using AND gate logic, 2 inputs are true, and we would have the carry turn on. So 1 button, 2 button, and precisely the carry turns on. So we have a true result when that happens. And the XOR logic is if we have 1 button down and the other is not down, we would have a result of the sum turning on. So that is also correct. That's also what happens.